Okay. Yeah. So I'm releasing this video because of your results on your quiz 4. I think the average was 70 something percent, so not that great. Yeah, actually it was 56%, so 57%, really, really low. So not good. So I'm going to release this video to basically go over the quiz for you guys since we haven't been meeting. But we will meet next Tuesday. So be sure to come to class and discuss the new unit. So the first one is talking about the occurrence of ecological fallacy. If you guys can remember, that's when a relationship changes when we look at the way we group the relationship. So this is related to the Berkeley study, which is another question later on. Basically, it's the nature of the relationship changes after this aggregation. So the way you grouped your data basically gave you one picture, and if you ungroup it and looked at it a different way, then the relationship changes. So that's basically that definition of ecological fallacy. Association and causation, I'm not really sure why you guys were answering for that one. Usually it doesn't go together because you can get an association and then you go in and do an experiment to get causation. Yeah, or you can do an experiment and calculate an association, but these aren't really related to ecological fallacy. You might think it's, the whole correlation does not equal causation, but that's not what the question was asking for at all. And yeah, so we had a couple of slides on that. This next one, of course, your famous table. I told you guys that you need to learn how to read it. So this is asking you how to calculate a relative risk index, basically a ratio. And this is the correct answer. And to get that answer, you need to record your current tab. Use the extension icon to switch the recorder to your current tab. You can also use this Alt Shift F. Shift F. Oh. I'm not sure what you guys are seeing. Where's my oops. Okay, so I'm doing the recording thing. I'm not sure which tab you guys were seeing, so that was the delay. So this is basically the reproduction of that table. And to calculate that, you basically want to take the students that smoke out of that row. So smoke out the total for that row. And the second part is this row. So student doesn't smoke and out of the total. And you get 1.33. The 1 is your anchor. So it's really the 30.33 that you're looking at. And that's why the answer there is 33%. More likely to smoke if both parents smoke than if neither parent smoke. I'll shift that. Okay, so now it's on the right tab. I'm getting the hang of this recording thing. Okay, so that's the answer to that. And that continues on the next one. It's approximately how many students should we expect to see? So now you have to calculate expectation, which is in your second association slide. And this is basically how to calculate. And that's slide 39. So near the end. Oh, sorry. Damn it. Okay, so now you guys can see it. This is your second slide, and it's slide 39, I think, of the second presentation. Expected count equals your row total by your column total. And you can calculate that, basically what I did here. You can see the row total, which is this guy, and the column total, which is this guy, and you divide it by the table total. And so you do that for each of these values, and you get your expected values. And this is expected values given no association. So you get the closest one's 130, and it's asking between student smoking status and parent smoking status. So that's student smoke, and parents smoke. So no association, 130.5. Let's answer that. Chi-square index for 2 equal to 4.6. What's the most appropriate conclusion we may draw? The answer is there is evidence. There is evidence, and that again is if you keep going down on this slide, this presentation rather, you get to expected tables along the same lines, and you get to this how to calculate a chi-square. And the takeaway message is this rule of thumb: if the chi-square is greater than 3.8, the data is not consistent with no association. So that means if it's not consistent with a no association, then there is evidence of an association. So that's why that's the answer. 4.6 is greater than 3.8, which RR index indicates a weaker association. So I mentioned that the RR baseline is 1. So the further you get from 1, the greater the association. So the weakest one is the one that's actually closest to 1. Chi-square can have. What hypothesis do we consider in calculating expected cell counts? I mentioned that it's a hypothesis of no association. Again, it's on that slide. Basically, what value would you expect if there was no association? It's your baseline value. We covered a bunch of slides on the phrasing of the questions. So what percentage of all plants in the US? So this should have been a pretty straightforward answer, right? I mean, all plants in the US, which is the appropriate denominator, all plants in the US. So don't get tripped up on that one. Suppose we have a 2x table of class attendance and grades, of course. Which of the following condition must occur before we conclude there is a statistically significant association between classroom attendance and grades? If any question has this stuff, it means it's going to be a very tricky question, and you have to decide on it, right? So the one that is wrong is this one. More students come to class than not, and there are more A's than any other grade. That doesn't necessarily have to be true for you to find a relationship. Yeah, not statistically significant association between classroom attendance and grades. Not necessarily true. Yeah, more students come to class than not, and so this one is the one that's not true. If I didn't do that right, but it's this one that's not true. You don't need a higher count in any one cell. So you need this value to be true, because then that means that there are two extremes where you can find a difference. So a lot of you kind of guessed at that. That was pretty good. Attendance grade must be measured by the same students, and the chi-square has to be greater than 3.84. So that's the standard to consider a significant association. So at least these two are true, which most of you kind of got. But that would mean at least 2 must be true. It turns out that there's actually 3 above. So again, which one following creates a larger association? Of course, the farther it is, 1, 1. I have no idea what this question's about. So this one's kind of tricky, and you have to know how to calculate a regression line. Basically, you need all these values. That's why they're giving it to you. And you have to, once you create that equation, you have to plug in 21. So how do you do that? Here it is. So to make a regression line, you need this is basically your regression line. You need the intercept, your slope, and x. So you calculate the b value or your slope. You need a correlation of x, y times the standard deviation of y divided by the standard deviation of x. So this is what that calculation looks. God damn it. Sorry. Here we go. So sorry if you guys didn't see that. Y equals a plus bx. And I'm going to get cut off in 30 seconds, so I'm going to have to start a new video. God, this is annoying. Can't even stop the video.